Welcome to this lecture where we are going to discuss Airflow's configuration file in some more detail. I have already given the glimpse of it in the Understanding Directories section, and I believe till now you would have understood the importance of this file. This lecture is focused to list down and give you a good revision of what all configurations we have covered so far. While some newer configurations will get added, earlier ones will be revised. Okay, so starting with the Airflow core settings, first we have DAGs folder, where all our Airflow DAG files reside. After coming quite a long way in this course, you guys must be familiar with this DAGs folder path. We have used it all the way throughout the course. Please make sure if you wish to change this path, then always enter an absolute and not relative path here. Next is base log folder. Base log folder defines the path where Airflow should store its log files. By default, it stores under the logs folder of where your Airflow is installed on the same machine. But yeah, if configured, then you can also store your logs into some cloud storage as well. Then remote logging. Airflow gives you the freedom to store its log anywhere other than local as well. So these remote configurations comes into picture if you have configured to store your Airflow logs on some cloud storage like S3 or Google Cloud. Since by default it stores logs on your local machine, so this property is set to false. But if you want to store your logs in cloud, then these configurations like remote server connection ID, its base folder and all, they all have to be set. I'll see if I can add a lecture in this course to store logs in a cloud. Then these again are all related to log settings, logging level, that is what level you want to log. By default it is info, but you can set it to debug, warning and error. Scrolling down, here is the default time zone. By default it is UTC. Then is executor. This has been already discussed. By default it is sequential executor, but since sequential does not support parallelism, so to scale you can switch to local or Celery from here. Then we have SQL Alchemy connection. We know Airflow uses some metadata database to store information about DAGs, tasks, their statuses. And its web server talks to that database to present us all this information in pictorial views, right? Now to connect the web server with its metadata, Airflow uses an ORM SQL Alchemy that helps to connect the web server, which is a Flask application, with the backend database. This is the default SQL Alchemy connection string to that database. Since by default Airflow uses a sequential executor with SQLite as its database, so SQL Alchemy connection is set accordingly to that SQLite database. But if you use any other executor like local or Celery, then SQLite won't be used. Then you will have to pass the relevant connection string of some robust database you will go with. In our project, this property is being set in entry point.sh script, so it was commented here. I'll comment it again. Then we have SQL Alchemy pool size, which defines the maximum number of database connections in a pool. It's 5 here, which means that at a time only 5 number of active database connections can be made. Scroll down. We have parallelism and DAG concurrency, which is already explained in detail in the local executors lecture. Next is DAGs are paused at creation. From the name itself, it is pretty much clear. This defines if your newly created DAGs should be paused or unpaused whenever it is loaded in the DAG list. Setting it to false will enable your DAG automatically. Then at line 108, we have non-pool task slot count. Guys, while creating pools, you are assigning a certain number of worker slots to a pool. But in case if you don't create those pools, then by default tasks are run with a default pool, the size of which is guided from here. So if you are not creating any pools, then by default task will be run with a default pool of 128 workers. Moving on, we have max active runs per DAG. This property defines how many instances of one DAG can run at a particular time. By default, Airflow allows 16 DAG runs at one instance of time. This property becomes important in case of backfilling. Remember the tutorial example? There, the start date of tutorial DAG was set to year 2015 and it was set to run daily, which would make it to run more than 1000 times if triggered today. I understand that no one would trigger such type of DAG intentionally, but to avoid the situation of accidental runs, this property was introduced. This property would allow only a set number of DAG runs at one particular time. Then is load examples. which we all know is to whether list the default example DAGs in UI list or not. By default, it's set to true. Plugins folder. In case if you have built some plugins for your application, then from here you can provide the plugins folder path. Then we have an important property, Fernet key, to encrypt the data. It guarantees that a message encrypted using it cannot be manipulated or read without the key. Any encrypted message will require a Fernet key to decrypt that message. Again, this Fernet key value is coming from entry.point.sh script. So these were some of the principal Airflow core settings. Then scrolling down, under the web server, we have base URL at which Airflow should point to. Since as of now we are working on localhost, so it's a localhost address, but in production it will be your live URL. Then at line 276, if you remember, each time when we trigger a DAG manually from Airflow UI, we were redirected to the tree view of that DAG, right? That default DAG view is set from here. From here you can change it to any view, graph, Gantt or whatever. Then DAG orientation accordingly is set from left to right. Scrolling down. Here we have the SMTP settings. If you are sending any alert emails from Airflow, you can configure the SMTP configurations from here. If you remember, this thing we had set in compose file for stored sales project. The same derivatives can be set in CFG file as well. Then we have Celery section where all the configurations for Celery executor are defined. So in case if you have deployed a Celery executor, its corresponding configurations you can set it from here. This worker concurrency is quite important and I have already explained it in Celery executor lecture. Next is under Celery we have broker URL. This also is an important property from production environment perspective. As we saw in architecture lecture, the scheduler puts the task in form of messages in the messaging queue, and from there they are transferred to the workers. Now the question is, who exactly will do that transfer? I mean, who will act as postman for those messages put in the queue? It is the Celery broker. Celery broker, like Redis or RabbitMQ, delivers that message from a queue to the Celery workers for execution. And here we pass the Celery broker URL for that. Get it? Now after the task has been processed and finished by the workers, whom should it report to? Where it should tell that the given job to that worker has been done. This is what a result backend defines. Celery workers report to the result backend upon task completion, which in turn is updated into the metadata. Then we have some properties related to scheduler. This one is important. DAG directory list interval. This directive sets how often the scheduler should check the DAGs folder in order to look for any new or updated DAGs. Guys, in our Airflow setup, when your scheduler is in running state, you may have noticed that each time when we create a new DAG, it never gets listed in the web server immediately as we create it. That is because of this property. By default, it is set to 300 seconds, means scheduler will scan your DAGs directory to look for any changes after every 5 minutes. You can change this time depending upon how often you update your DAGs. Then we have catch-up default property. This property, when set to true, will start backfilling of your DAG if the start date is less than current date of its execution. By default, catch-up is set to true, which means any of your DAG whose start date is set before the date of its execution will automatically start backfilling of the missing DAG runs. But sometimes this backfilling can be overwhelming for your systems where you have resource-intensive DAGs with pending DAG runs. So as a precaution, you can set it to false from here. Anyhow, if you wish to turn it on for some DAGs, then you can set it to true in your DAG file. And I guess that's it. We have covered all the major configurations that are generally used in Airflow. Good thing about this CFG file is over each configuration, a well-detailed description of that property is defined in comments. So anytime if you are doubtful with a property, you can always refer to the comments given above it. Thank you.